Now, first things first, I've given you 3 data sets here, okay? So a data set is just simply a collection of numbers with some meaning between them. So it could be heights, it could be marks of people in a class, it could be ages, it could just be any kind of collection of data, okay? And I've got 3 data sets here. Now, what I want you to do, and you can do it kind of in your group, so you can do it on your own, it's up to you. I just want you to decide on one value that you think best represents each data set. Okay, so just looking at it for maybe 30 seconds, which number do you think best represents each data set? So you should have 3 numbers. Okay, so 30 seconds. What do we reckon? Okay, so for data set A, we've got the numbers 2, 4, 1, 3, 2, 2. What number do you think best represents that data set? 2? Any advance on 2? 2? Yi, what do you reckon? 2? 3? Vatican?
No,
2? Vatican? 2. Go for it. Follow the crowd. Okay. Okay, fine. What about data set B? What number do you think best represents it? It's got 5, 6, 7. 6, 6. Vatican? 5. All right, good. And then data set C, got 2, 4, 1, 5. What number do you think best represents data set C? 3. Vatican?
It can be a number outside of this data.
Yeah, it can be any number you like.
Yeah, 3.
3? What do you reckon, Vatican? 3? Yeah? Yi, 3? Yeah, Megan, 3? Okay, good. So what I'm trying to get you to do here is understand the idea of a measure of central tendency. In other words, when you're looking at data, and I do this, like I look at data quite a lot, I try and get a feel for the data just by coming up with a number that best represents it, okay? Does anybody know what we call that? So if you come up with a number that best represents a data set, does anybody know what name we give to that? It begins with an A. Go on.
Average.
Yes, absolutely. Yeah?
Average.
It's an average, right? So an average is just simply a number that best represents the data set. So instead of working with a data set with 1,000 numbers in, you can just pull out one number that you think best represents it. And that's what's known as an average, okay? So that's where we're going to start today, okay? Now, actually, we don't call them averages. I mean, we do, but a better name for them, or a better term for them, is a measure of central tendency. Okay? So a measure of central tendency is simply where the center of your data tends towards. Okay? So where the center of your data tends towards. Okay? And yeah, you're right. So if you want to use the word average, that's fine. A better term for it is a measure of central tendency. Okay? So either one of them. Now, are you happy there are 3 measures of central tendency? So 3 measures of average. They all begin with M. Okay? So what's a mode? I know I've put it on the screen, but you don't have to give me that. Sorry? Yeah, exactly. The most common number, the most repeated number. Fantastic. What's the median? Vatican, what's the median? Yeah, it's the value in... So you have to order the data set first. Now remember, it doesn't matter whether you go smallest to biggest or biggest to smallest, as long as it's in order. And then you just simply choose the middle value. Okay, it's the value slap bang in the middle. Middle, median, medium kind of thing. Yeah. And then mean. What does a mean?
It's when you add all the numbers and divide them by the number of numbers.
Absolutely. So you add all the numbers together and divide by the number of items in the data set. Now that's the definition. That's like how you work it out. But what is the mean? What do you reckon? It is a type of average. It is a type of average. I mean, what a mean literally says is if all the numbers were the same value. So you've got a data set, I don't know, of maybe 4 numbers, okay? And when you add them all together, you get 12. Now, if all those numbers were the same, what would that number be? What would that number be?
12.
So you've got 4 numbers in your data set. You add all of them together, and it gets to 12. What would that number be? It would be 3. Okay? Because what you're basically saying with a mean is if all of those numbers were exactly the same value, they would all have to be 3. Okay? Hence the reason why when you add them all together, you get a sum, you get a total, and then you have to divide them by the number of items in your data set. Does that make sense to everyone? Yeah, good, fantastic. Okay, so can you for me work out the mode of each of these 3 data sets? So each line is a different data set. Can you work out the mode of each data set for me? So, what do we reckon for the top data set? We've got 3, 5, 8, 5, and 2. What is the mode?
5.
5, good. Why is it the mode?
The most common number.
Exactly, it comes up twice, whereas all the other numbers only come up once, okay? The next data set, 13, 62, 13, 13, 25, and 60. What's the mode? 13, good. And then the bottom data set, 1528219. What is the mode? 1 and 2. Now, interestingly, that data set has 2 modes. Does anybody know what we would call that data set then, if it's got 2 modes? We call it bimodal. Bi meaning 2, okay, and modal meaning obviously mode, okay? And obviously if you had 3 modes, it'd be trimodal, and then 4 modes, it'd be quadmodal, etc., 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 okay? Now, I said right at the very beginning that the whole point of a measure of central tendency is to get how many numbers?
The measure of one number.
Should just be one number, right? Should just be one number. So here, interestingly, we have more than one number coming out, okay? That's not necessarily a bad thing because actually sometimes it might be bimodal, but this is one of the limitations of having mode as a measure of central tendency. Sometimes you end up with more than one number just purely by chance. Your data set isn't accurate enough, not big enough. Is that okay? Good. Now you notice as well with this, you don't need to order your data sets. You don't need to put it smallest to biggest or biggest to smallest. Is that okay? Because you can really easily see which number is the most common. Okay? Good. So there you go. There's the modes of those data sets there. Okay, let's have a look at the next one then, the median. Okay? Now, have a look, because I've given you a formula there on the right-hand side. By the way, there's the median data set there as well. Have a look. If I want to find the middle value, surely I should just count the number of items in my data set and find the one halfway in the middle, wouldn't I?
Yes.
Why?
That'd be easy.
Kind of. Would I have to do anything first before I find the middle value?
Depends if it's an even number of items.
Yes, it would, but would I have to do anything to my data sets before I find the middle value?
Make them in order?
Exactly. So either biggest to smallest or smallest to biggest. So make sure they're in order first, then you need to find the middle value. All right? Good. Now, how do I find the middle value? So let's suppose my first data set, I've got 3 items in my data set. And I say, well, okay, the middle value should be the one slap bang in the middle, so halfway. So what's half of 3? 1.5, right? So I'm basically saying that the median should be at the 1.5th value. Is that right? Why?
I don't know.
I mean, have a look. My first data set has 3 values. What's my median?
Median is 3.
The median's 3, the one at the second position, right? The one at the second position. So it's not just as simple as taking the number of items in your data set and dividing by 2. What do I have to do? Yeah, m plus 1 divided by 2, right? Because what I'm saying here, if I've got 3 items in my data set, my middle value should be at my second position. So let's check it. 3 items, add 1, what do I get? 4, then divide by 2, and then I find it's at my second position, okay? So have a look at the next data set down, 43, 50, 60, 102, okay? How many items are in my data set?
4.
So if I add 1 to it, 5 divided by 2, 2.5. So I'm basically saying it lies halfway between my second and third value. Is that okay? So what value is it going to be? What's my median going to be?
55.
Absolutely. So if you want to find the middle value of 2 numbers, it's basically just the average. Add them together, divide by 2. So it's 55. Happy?
Yep.
Good. And then the bottom data set, how many items have I got?
5.
Add 1 to it,
2.
divide by 2.
3.
So it should be my third position, which is going to be
43.
43. Fantastic. Is that okay with everyone?
Yep.
Yep. Now, is the median always going to give me one value?
Yeah.
Yes, absolutely. The median is always going to give me one value. So whereas the mode might break down because it might give me more than one value, the median will always give me one value. So it satisfies the definition of central tendency. Okay? All right, let's have a go then at the final one, which is mean. Could I ask you to have a go at finding the mean of all those data sets? So it's the next page along. For the mean of the first one.
3.
3, good. What do we get as the mean for the second one?
40.
And what do we get the mean for the third one?
50.
50, cool, excellent. Okay. Does that make sense how we calculate the mean?
Yep.
Yeah. Is this all fairly familiar to you? You've all looked at this before? Mean, median, mode, measure central tendency, etc., etc., etc. Good, excellent. Now you notice as well, we had to order the data set for finding the median. Do we have to order the data set to find the mean?
Of course not.
No, absolutely not, because we're just going to add them all together anyway. Yeah? Okay, good.